cookware's remarkably slippery surface. In 1938, an American chemist was experimenting with refrigeration gases. A waxy substance formed. Years later, when bonded to cookware, it gained a non-stick reputation. When it's time to fry, using a non-stick pan averts a messy situation. The non-stick coating is one of the slipperiest solid materials on Earth. Called polytetrafluoroethylene, the name is a bit of a mouthful, but the appeal is simple. Food won't get stuck on this non-stick surface. To make the aluminum pan, they use 70% raw material and 30% leftovers from prior production of pots and pans. They fire it to a molten state and filter it to remove contaminants. The liquid aluminum flows into vertical rectangular molds. A jacket of water around the molds cools the aluminum to take it from a liquid to a solid. A crane extracts the cast slabs. They're heading to a heating chamber to soften the slabs. This will allow the metal to be shaped and formed. A saw slices the slabs in two and trims the ends. More blades scrape the top and bottom to remove impurities. A conveyor repeatedly feeds the shorter slabs to heated rollers. Guides at the side maintain the width, while the rollers compress the aluminum, taking the thickness down to about ½ centimeter. The rolling also elongates the slab substantially. It starts out 2 meters long, and after a few minutes of rolling, it's been stretched to well over 100 meters. Pizza cutter-style blades trim the edges of the aluminum sheet. Another roller winds the aluminum into a big coil. Then they unwind it and squeeze the aluminum to flatten it. Machinery now pulls the long aluminum sheet forward to a 120-ton punch press. This powerful press forces the metal around a frying pan-shaped die and then punches out the shape. The freshly formed aluminum frying pan falls onto a conveyor below. The leftover aluminum will be used to make new frying pans. The pans now ride a conveyor through a washing station, where they're cleaned and then treated with sodium hydroxide. This opens the pores of the metal to allow an enamel coating to stick to the outside and the non-stick finish to adhere to the inside. A worker inspects the pans and places them upside down on spray fixtures. It's a tight fit to shield the inside from the enamel spray that comes next. The pans spin on the fixtures and twirl by the spray nozzles for an even application of enamel to the exterior of the pans. A glossy clear coat follows. The frying pans transfer to a dryer conveyor. The hot air pulls out water from the enamel coating, and the color goes from gray to chalky white. An automated squeegee silk screens the company name and other information onto the pan bottoms. They now enter a long curing oven, heated to 560 degrees Celsius. The cure toughens the enamel, deepens the color, so it turns gray again, and it adds gloss. A suctioning device picks up the pan and turns it around for the inside coatings. A sprayer applies a special primer that will make the non-stick coating adhere to the pan. It then applies the non-stick coating. The pans receive 2 layers of this non-stick synthetic substance. The suctioning device releases the pan and it lands upside down. Then, the pans journey through the oven again to cure the non-stick finish at around 425 degrees Celsius. On exit, water rains down to cool the pans and rinse off any contaminants. Then they go through an infrared light chamber to dry off. From a plain shell to a pan with an enamel finish on the outside and a non-stick coating on the inside, the transformation has taken just 1 hour. A worker now aims a laser and aligns it with lettering on the bottom, allowing him to punch holes in a precise location on the side of the pan. He slides pins into the holes and slots them through holes in the handle fitting. Using a ram, he flattens the pins to rivet the handle to the pan. Now, no matter what's cooking, cleanup should go smoothly.